Okay, I think we can get started. So once again, thank you everyone for joining our Building Smart USA webinar series. For those of you who are new to this webinar series, it happens every second Wednesday of each month. And today we have Chris and Jerry from the Building Smart USA Digital Twins Airport Group. Chris, Jerry?
Hi, welcome everybody. We're going to give you a little bit of a insight into our work that we've been doing with the airport room in developing components of digital twin to help kind of demystify it. So that's the title of our work. Just to give you a quick background of who I am. I'm Jerry Schwinghammer. I've been involved in the airport industry for a very long time, doing a lot of CAD and GIS work for like Orlando International Airport, as well as doing all the master planning and those sorts of things. And in addition, I was a chief technology officer for Charlotte Douglas International Airport. So I've seen just about every flavor of computer system and thing IoT related that there is. Not that I have a full understanding of it, but I know what it is. And I've been very intrigued by the whole concept of digital twin. And that's been my recent focus, exploring that as well. Chris, if you want to give a brief intro.
Sure. I can try to be brief. So I'm Chris Harmon. I look after digital delivery and innovation for the WSP US transportation business. I do have a background in aviation. I'm a civil engineer, and I spent quite a bit of time as an airport civil engineer, project manager. I'm based in Atlanta, so I worked at Hartsfield quite a bit. And so it's near and dear to me. I think one of the great things about airports is that their projects are complicated and multidisciplinary, and they require a lot of kind of, next level or advanced delivery processes. And that's kind of how I made it. The digital delivery side, doing BIM and, information management is a full-time gig just because of that background. So it's a cool space for me to work in. So digital twins, obviously, very in vogue lately. So I'm excited to talk to you all about it. Jerry, you want to talk through the working group?
Sure, absolutely. Thanks, Chris. The working groups are overall headed by Cindy Baldwin of VDCO Tech. Thank you for Cindy for helping orchestrate all those folks. We have broken into 4 different areas. 2, 4, 5, excuse me. That's the BIM to GIS work group, the airport simulation work group, and a data work group, and an owner's think tank work group. And I welcome you to come to our site under buildingSMART USA. Make sure you put the USA in there. There's the web page. Take a look around, see what we've been up to. If you'd like to participate, we have folks come in all the time, so I encourage you to explore and also join us. One thing I'd encourage you to do, if you're particularly interested in some of this stuff, drop your name and your email in the chat so we could pull you into some of this work, give you an opportunity to do some whiteboard sessions and just some good thinking process work with us. So I'll offer that out as well. Okay, I think that's kind of a quick intro. So our process, Chris, I'll speak to this briefly, and then if you want to jump into it, that's all. So we're using kind of an organic process, leveraging a mural whiteboard, just kind of tease out the various complexities of what we're doing. And Chris is going to kind of show this. Why don't you take a moment and just talk a little bit, Chris? You're kind of the de facto expert.
Yeah.
I wouldn't want to misspeak.
No, absolutely. What you're looking at is actually, it's a Chrome. It's my web browser, and this is our working group's mural board. We've kind of moved everything in here. We had tried several different ways to manage everything we had going on, and because it's such a dynamic space, and getting together and kind of thinking visually helps. We just started using a whiteboard. It has the ability to do presentations, so we've made a kind of running order bits, but this is where we're working, and this is kind of like our mess that we're bringing you into. So we're trying something new. So it's not a PowerPoint, so it's not polished. This is actually where we work, But hopefully, you all appreciate it, and it's a new way to kind of go through it. It's going to feel a little bit PowerPointy at times, but we always have the ability to zoom out or move around and go in and dive into places. So like these virtual whiteboards, Jerry and I are both in this. I think if you move your cursor around, Jerry, everyone will see the name that it's lovingly provided to you, which is visiting hippopotamus. I think Jerry's going to be kind of like pointing me in places. So if you get a little seasick at times, I apologize. Like I'm going to dive back into this slide, and it's going to be jumping around some. But we're going to jump around and show you the actual stuff that we're working on and kind of how we're thinking, because like everything, this is not done. We are in the middle of it, and so you're kind of getting a window into where we are. And I guess with that, Jerry, I'll probably hand it back to you.
Yes, please. That'd be great. So, all good things are even better with frameworks, and I really love frameworks. And what I've got here is the Gartner hype cycle. For those of you who are familiar with Gartner, you're probably familiar with their hype cycle work. And if you're not, please take some time to get familiar with what they do. They're a technology research company with just volumes of information about technology for decades. And one of the things they do is define a hype cycle. So technology is exciting, wonderful, new, I'm going to try it. And then people are like, oh, that's not so great. It's not so wonderful. And Chris, could you zoom in on the lower right diagram? I'm going to just kind of talk a little bit about that for a moment. This is an old one from 2010, and you can see, where there's new technology triggered, peak of inflated expectations, and then the god-awful trough of disillusionment, and then the slope of enlightenment and a plateau of productivity. So this is kind of a cycle that people feel technology has gone through. And if you take a moment and look at some of these things back in 2010 that were emerging then, say like 3D printing, private cloud computing, like we're like, oh, that's just buzzword, that's all hype. Well, guess what? That's all very real, very much present, and it's what we do. Some things have fallen by the wayside, though. Like if you look at that little red dot, broadband over power lines, not so much. That's still a hard technology that's not ripened. So you start seeing these things, and everything goes through a cycle. So digital twins go through a cycle. And could you back out to the full slide then again? Let's go and look on this thing here closely. So as of July of 22, the Gartner hype cycle has put the digital twins in the trough of disillusionment. Okay, that's kind of where they peg it. So it's exciting. People know it's valuable, but it's not going to slice your bread or run your airport. It's not going to do that. If you slide a little bit to the right, I like this format. This is great. You can kind of see what has to happen here, where you see this consolidation and shakeout of vendors. People kind of like, well, show me the ROI, show me the value prop, etc. And then ultimately in there, in order to make it all happen, you have to have methodologies and best practices and develop them. And that's what we're doing. That's what this team is involved in, is shaping the future for what is involved with digital twins. So there'll be new softwares. It won't be just about software. We're going to talk a lot about business case and use and value propositions and how you assemble a digital twin and how you go about it. So let's just zoom one more down into the lower left there, and we're just going to kind of give you a few little samplings of some of the things that I see as beacons on this slope of enlightenment. We're going to be transforming the notions of inspections. Like you do this massive triennial inspection once every 3 years, or you might do a daily inspection of the entire airport, or you might do, like airfield inspections for Part 139. You got to, get in the truck and drive. Well, if you knew the condition of everything and you had visuals on it, you could do this dynamically and always be inspected and always ready. And that takes a lot of change. It's not just the technology, but you have to get the approvals to say that's the way we want to run things, etc. So you transform the way in which you do business from sort of this rough and ready way of looking at everything, right, to maybe just looking at the exceptions and very focused. And then I've talked a little bit about remote situational awareness. Right now, everybody's like, oh, I know where everything is. You don't need a twin. But those who don't know where it is, so you want to pull in the FBI or the TSA from the federal headquarters, but you don't want them on your property. You just like, here, let me give you a visual into the world, and they can see where they are. So that's a growing thing that will ultimately become a value prop. I talked a little bit about auditing and business continuity, test your practices, in virtual, not in real. That's a great thing for tabletop exercises. Asset tracking and tracing. There's some really cool things with the new digital twin technologies, leveraging graph technology. I was involved at a DFW about that. And it's kind of the next level beyond SQL databases. And it's all about the relationships. So as one of the folks, Sean Clan would always say, it's like you take a light switch and you know what room it's in, and you know what temperature's in that room, and you know what power's feeding and what light, what circuit breakers, and who's leasing that room. You can get that all coalesced together rapidly, which is good when you need to respond quickly. So there's some new technologies that are underpinning digital twins. And in addition to that is, the standards development. It's going to force the need for standards. And we'll talk a little bit more about that in a bit. Anyway, ultimately, I have this thing the best way to handle risk is to eliminate it. And we'll talk a little bit more about that as we dive in here. So I'm done with that slide. Thanks, Chris. If you could move me on just a bit. So, maturing digital twin conceptual framework. Some of you may be familiar with the TOGAF framework, the Open Group Forum. It's kind of an industry standard. You adopt these frameworks. Effectively, you have the business layer, application, technology layers coalescing together to create a cohesive technical environment. In the upper left, you see there's the notion of twins. This is also from Gartner, is the discrete twins, where you have information about a particular escalator or baggage handling device or whatnot and its status. And then you kind of go up a level higher into more of like a building or a runway. Maybe you just substitute those in there. And then at this organizational level is where you bring it all together, so you can have alerts across the airport, complete situational awareness, pulling prediction things together and the like. So it's not one thing, it's this composite, composable notion of twins. And Chris is going to do a great walkthrough exercise with that, and so I'm going to make sure to leave him time to do that. And then here on this maturity model, you see these out there, and this, initial, repeatable, defined, managed, optimizing. These are kind of standards out in the industry. We've all experienced them. But I think when people start talking digital twin, they're going to be forcing this front and center. You got to be mature in order to make it happen, or you got to be able to mature rapidly or have a scalable approach to maturing. So that sets the context and the framework. And let's drop into the pieces, Chris, a moment. So I've had the good fortune of being involved with the AAAE, the American Association of Airport Executives, Airport Digital Twin Working Group. And, they've come up with, there's a bunch of airports involved in this, some consulting companies, some software technology companies. And, they said, well, give us your top ones so far. And this is what they've done is, landside and airside modes of transportation capacity. What's the curb doing? What's the airfield doing? What are the taxiways? What's the gates? It's, an airport's about moving things. So where are we capacity wise? Where are we weight wise in terms of bus schedules and times, throughput, security checkpoints, again, throughput, what kind of activity in the terminal this can translate into revenues for concessions, et cetera, and routing opportunities, et cetera. So you can kind of go through these, planning for flight schedules and all of this, predictive maintenance on the infrastructure, work scheduling impacts and what might you take out. So what you see on the right is a delineation of can you zoom in just a tad for old eyes here? What we've got is optimizing the security checkpoints at Charlotte Douglas International. So they would love to be able to optimize them. And so you have this visual depiction of the checkpoints, where the people are, the counting of them, et cetera. And then you got into, so the use case, why would you do it? What's the description? Contributing systems. And this piece fits back into that architecture drawing I was showing you earlier. You know, you got to do your requirements work. You can't just go buy this off the box and drop it and transform. Most of the work is going to be the hard work that you got to get at a whiteboard basically and do. And so we thought, well, let's eat our own dog food, right? Try it out. Let's do this. Let's make this real. And so we're working on this, and this is a good illustration of things that are happening when you go to do a digital twin. So you want to look at the challenges, the frequency of the data, who's the stakeholders, who do you have to involve, et cetera. So there's organizing it, orchestrating it, and then turning it into components and parts. So yeah, let's do a deep dive a little bit.
Yeah, I mean, this is the AAA, they produced that document, right, Jerry? There's like
it's not out for publication yet, but shoot me an email or drop me a note on the thing and say you would like to be aware of that as well, and I'll make sure we get plugged into that. Go ahead, sorry, Christian.
Well, no, I was just going to say, we essentially just stripped out all of those use cases and started organizing them in our working space, because it gives us a really good target of, what is it that airports are aiming at and how do we achieve that? So is that roughly right, Jerry?
Yes, it is. And you saw the close-up of one of them where you kind of peel it apart and look at the value. And so there's nothing mystery about it. It's hard work, and you get down to doing it. And there's some illustrations of some of that, and you'll see a lot of variability in how they approach it, and the tools out there. So it's still quite a bit of shakeout. A lot of them are GIS based, or some of them are kind of more BIM centric, and some of them are really just what do you call it? The analytics based reporting abilities. So business intelligence tools. So if you want to back out just a moment and show where the airports are, and do you want to, what do you think, Chris? Were we going to scan through those now, or we can do that a little later?
I think we'll do it later. I think if you want to bring us back kind of.
Yes, please. Yeah. And so I'll bring it back for us, and then we'll get to, work here. So this whole notion, you think you would benefit from a twin, you can set up a framework, and then you go, well, where's kind of the rubber meet the road? Where's the real value that says I should do this? And I think it comes into the value of predictive analytics. And this graph shows a couple of things that really undergird what it is. And I'd say the best way to avoid risk is to eliminate it. Just don't even experience it. Just don't go there. So let's say, for instance, we have a baggage handling system and part of it fails. One of the bearings blows out and we lose a segment of that system. Or it could be a train and you have bearings fail and you got a derailment and you got an awful mess. So those are the kinds of things that you want to clearly avoid. And that's that point. F is the functional failure down in the lower right. That you really just want to not happen. So you kind of go back up and go left on that. So there's things that you might been able to detect. It wasn't working properly, or it's hot to touch, or it's making a lot of noise. So if that baggage system's just clunking away, you go, oh, that's a problem. Let's fix it. Well, sometimes it won't do that. It'll just fail. Or you won't hear it, or you'll ignore it, or whatever. But you can go further back and say, well, why did that fail? Was there some kind of, could we have done oil analysis? Could we have done something on it? Or what if we actually had sensors on it and we could predict, vibration, or even go back to, even real fine sensors on ultrasonic testing. So this is the realm where the human is not involved, things you would not detect. You're living with an unknown risk that you have no clue about, but yet could be extremely problematic. I'll give an example. When I was with Charlotte Douglas International Airport, the airlines handed the baggage handling system over to us as part of some of these renegotiations that everybody goes through, and we would manage that because we had more airlines coming on board, and we were going to provide that as a common service. Well, the director said, well, Jerry, what kind of risk are we looking at here? And I said, well, okay, let me look at it. And I said, well, the nearest I can calculate, we're looking at, if that system has catastrophic failure, we're causing the airlines a burn of about $1 million an hour. And so all of a sudden it became very real about fixing some of this stuff and getting smart with it, and let's tune this baby up, let's replace things, let's do things. So, but he didn't know the risk level he was living with, and I think a lot of organizations probably don't. And part of one of the challenges is that you're going to expose some of this risk, that people are living with, and you might want to come back with something. Here's some things way we can mitigate it. So you can use a twin as a mitigation tool, a comprehensive alerting of situational awareness, mitigation tool, business continuity testing. It's all these kind of optimization, mature types of things that you can do when you build it correctly. You can't just throw them a software and say, yeah, it'll work. No. It's really taking a re-engineering of processes involved in it. So I think that's probably a good pivot point, Chris, if I want to hand it to you and walk through how you put one of these together.
Yeah, I think we had one question come in, which was from Christian, about what comes first, the digital twin or the physical asset. Which is kind of, I'm having like an existential crisis right now. Epistemology. I think we'll talk a little bit about that. I think that what Jerry's talked about is kind of like what we're all feeling maybe a little bit, which is that we've been hearing a lot about digital twins, we've been talking about them a lot, but what are they? And because we're working on this with airports in mind, and this is our kind of working mess you see on the screen, we've taken a very tactical or practical approach, and it's one that I started with. There's a WSP property and buildings digital twin framework, which we kind of just like took and distilled down into some basic parts. So I'm going to run through what we are calling this framework for digital twins. Like, what is it that makes a digital twin and how you put it together? Kind of building on what Jerry's is set out, and then kind of try to show you how we're using it in this airports working group and how we see it as being applicable. It doesn't have to be airports. I mean, it's kind of work for everything, but I want to do that little setup before I just dove in. And so this is I call these the components of a twin, or the digital twin, framework, and it should start with those strategic outcomes, right? With the outcomes that you're aiming at. And that's, I think when Jerry's talking about that risk, like our clients don't really understand the risk. Sometimes we're pointing this out, and we're also sitting down with them and whiteboarding out, like, what are the things you're aiming at? Some consistent feedback I've heard in the same kind of, that trough of disillusionment is like, what can I do this year? Because if you come in and tell me that I can have a digital twin, if I break down every silo in my organization and invest 100 million across all of them from an unknown funding source, well, guess what? It's not happening, So like, what is it that I can do this year that's going to make this happen? So we always sit down and start with these like strategic outcomes, and then we try to take that and work it into some requirements for a twin. And I haven't gotten your question, Christian. I promise I'm going to get there eventually. It takes me forever to get anywhere. So what we do is we start with those outcomes and then feed that in through a set of requirements to what we need in a digital twin. And, essentially that is broken down in our industry. This is where it starts to get real tactical and practical, but into two basic buckets. And that's static data, static information, and dynamic data or dynamic information. And so an example of static data would be like your BIM models. right? GIS, dynamic data like sensors, CMMS, so that's computerized maintenance management systems. Thank you. Financial information, program, those kinds of like dynamic changing business systems, that's stuff that's there. And we've had this split right now. We've got these static BIM models, we've got these sensors. And I just want to stop for a second and say that up to this point, we have not said the words digital twin yet, right? And that's because what we want to start adding in to this, coming out of those two information types, or those two components, those big components, is a simulation and analytics engine. I mean, Jerry just talked about the importance of, artificial intelligence, machine learning, digital information management, because that is going to be, it's going to be able to do a lot more than humans would, right? And I think we're not going to get there unless we have the ability to start simulating and analyzing the information coming out of it. So that's the twin, right? And that, I think that this is, in kind of a long roundabout way, how we're talking about digital twins now. It needs to be something that would offer insight. You learn something, you get something that's out or beyond what you would normally get to achieve these outcomes. It's not enough to call your BIM models a twin or your existing conditions model a twin unless it's achieving those outcomes through some sort of insight and manipulation to achieve that. And this is, I mean, that's a very tactical kind of explanation of it, or practical. And that's where we wanted to start taking those outcomes and use cases that have come in, that we're getting from the AAAE work, that we know from talking to our clients, things that they really want to hit, and start feeding that in on that right-hand side so that we can work back to the left and see what they can do. Because a lot of times, to that what can we do this year question, if you've got a list of things here and you know what you have here, you can find some quick arrows. Well, if you take this that you already have and this thing that you want, we can actually just put these two things together and then you can see them and there you get it. That's what you do this year. And that's the importance of kind of having this framework. So what that looks like in practice is this kind of mess that we've been working on. It took us a while to get here, and I'm gonna talk about it. I also wanted to show that WSP slide that we stole it from, because obviously either they have a graphics person or they're better at graphics than I am, because this is pretty, right? But you can see, like, you develop your strategic outcome, you got your BIM models, common data environments in there, and the static data. IoT connect, this is buildings, right? So that's their big thing, and these are their ideas about dynamic information, right? So their static is BIM models and their dynamic is lighting and HVAC and IoT on their equipment. And that's the active data. And then digital twin in red, it doesn't come until you get here for simulation analytics to achieve these things that are really important for buildings. And I liked this. When I saw it, I was like, oh, okay, well, we need that for airports, right? Like, what are these things for airports? What are these active data for an airport? Like, how do we get to that?
Yeah.
And so, go ahead, Jerry.
Chris, and that might feed into a larger strategic initiative around like zero carbon emissions or energy. So it really should start with that large strategic initiative and then kind of keep zeroing in on it so that you get to something that's absolutely relevant, excuse me, to the question at hand. So you don't have to sit there and explain why are we doing it. So like, well, because we save energy at X amount, and our organizational commitment to our board is that we do this. Oh, okay, here's how we can prove it.
Yeah, it is interesting to see the number of, and I know this from doing it for other orgs and other industries, the number of like organizational requirements just in terms of reporting. I mean, funding sources are tied to compliance, and compliance comes from reporting. And by far, and it is not a really exciting use case, and oftentimes does not require that much fancy BIM and 3D models, but by far the thing that most triggers this kind of workflow is, if you could just get me my reporting, then I could get my funding. Can you get me more funding? Can you make my reporting look better? Those are the big ones that we see. And if you look through the the use cases, there's a lot of TSA in there. There's a lot of security. There's a lot of wait times. There's a lot of passenger experience. There's a lot of stuff in there that I think we come into this not thinking is going to be really important, but it's fundamental to the way the organization works. And we need to start kind of shifting our thinking in that. So what did this look like for us as we've started working through this? Again, this is still work in progress. And this is where I'm finally getting to the question of physical entity or the twin, which one comes first. And I think for us in this application, there is an answer to that question, and that's that the physical entity comes first. You know, we're going into an airport in this instance, and we're saying, hey, like, what's your system or your physical entity? I would say also physical asset doesn't necessarily, doesn't have to be a physical asset. It could be a system that gets incorporated into the twin. So something that's, but I don't know if that's where your question was aimed. But we would want to start with that.
Yeah, Chris, on that for a second with you. So let's say it's a runway light out there. It's a physical asset. It exists. It's there, and it's on your ALP, and you might have a 3D model of it. I don't know, but you could twin it without even touching it. You know, it's like if you had a camera doing operational analytics, is the light on or not? You know, those kinds of things. So the order in which these things come is not necessarily cast in stone. You know, you can change it, and you can come with the assets first and then augment with different types of connections, or you can completely model it in virtual and then build it. And I think it could go either way. That's my take on it, Chris. So I think it kind of depends is the answer from me.
Yeah, and do you want to, there's a question from Matt Blake about, does buildingSMART or either presenter have a definition of digital twin they are working from that has been widely accepted? There's more to it, but I think that's a good one to start with.
Well, we've been working with a lot of the definition from the Digital Twin Consortium, and that's been kind of blended with the AAAE's definition of digital twin. You know, basically linking live data with physical assets and deriving information from it and doing predictive analytics against it. So I think it's inherent in the diagram, and we can kind of speak to it as we go. But those are the definitions that we've been working off of rather than trying to invent our own.
Yeah, I think just from my side, there are published definitions that we're working from, and they're not all the same, but typically the components are a virtual representation, physical asset or system, and then deriving or driving some form of insight or further use, right? And there's a, I mean, and so instead of having, because mine is even worse, I think it's extra wordy, and I won't get it right if I do it right now, Matt. But instead of aiming at that definition, the one that we are working from for this, and I think that there's quite a bit of agreement amongst us, is this kind of framework whereby the digital twin that we're discussing is the simulation, analytics of, or interpretation or service of this combination of static and dynamic information to achieve that strategic outcome, right? That's where all of those definitions are kind of aiming at that end result. And this is where I think maybe this is going to make you happy-ish. This is where we're starting to get a lot of agreement, because if we focus on achieving an outcome by doing something with this information, we have created a twin. And I'm starting to suggest that we stop. This is kind of getting into I'm off the rails now, but I've started to say, like, well, why are we calling it a digital twin? Can we just not call it a digital twin? Can we just call it the whatever the thing it is, like the baggage handling system maintenance monitoring platform? If you just call it that, everyone's happy, right? Yeah. Everyone's like, oh yeah, that's what it is. That's what it does. I actually need that. Can you just give me that thing? That's what I asked for. When you call it a digital twin, they're like, well, why doesn't it, operate my baggage handling system and deliver my luggage to my door. It's like, well, I was never supposed to do that. It's because there's so much, I think, confusion about what is that, what it actually is. And if we can take a step back from calling everything a twin and really focus on those outcomes and in a framework, then we can start to, I think, get a lot more agreement from everybody about what we're going to do this year, right? That's the key.
And Chris,
Okay.
just to build on that up just for a little bit, is that ultimately you're going to enable an asset management system with digital twin capability. You're going to enable an alert management system with digital twin capability, i.e., you're going to dynamically match flow data, static data. And I don't know where it's actually going to shake out. You saw that cycle. Some of this is still kind of in flux and play. Just to give you a heads up, the Airport Cooperative Research Program, ACRP, is in mid-flight on a digital twin study, and they've been doing this work. I've been working with them a little bit, and there is going to be another section about going out into the airport community and say, what does it mean to you? So I'd keep your eyes peeled for that, because ultimately, at the end of the day, that's what matters. Does it help your organization?
Mm-hmm.
Okay. Just noting in the chat window, Chris Frey has added a URL to the buildingSMART work group on digital twin, and the buildingSMART moderator has given a link to the most recent working paper from buildingSMART on digital twin, which is approaching 3 years old, but it does have a definition in bright blue.
Yeah, and I think I'm going to go through this a little bit more, and maybe it'll start to solidify, I think, because I think if we talk about what we're doing, that'll help. You can kind of see as we work through it. Oh man, my requirements dotted line got messed up. Now we're working on the fly. All right. Well, what is spatial data? Spatial information, lease data, BIM. What is dynamic in real time? Sensors, financial, EAM. What is the ultimate outcome that airports should really be aiming at? Is it physical control of their, like digital control of their physical asset via AI? That kind of like, that's where we want to aim. Like, how does that tie back in? And we started mapping this out, and what that led us to was, okay, this is a good framework for us to start working with. We have this committee of the GIS team and the simulations team and the use cases team, the data team and the think tank team, the owner side. And where do they fit into this? I'm going fast now because we're going to run out of time for questions. So now where do they fit? And you can kind of see, and because you start with the outcomes and you feed them into the inputs, everyone is everywhere. But you can kind of start to see that amongst our working groups, there's a weighting. There's more, purple and kind of orangey brown on the left-hand side, and there's more pink and blue on the right-hand side. They're focused on those outcomes. They're focused on the use cases and the needs. The left-hand side is focused on the inputs, the requirements. And then there's this data piece that kind of like feeds everywhere and goes all throughout. And we started to say, okay, now we start to understand who needs to start thinking about what, where, and who's setting these standards. And then we started thinking about what standards are there, right? And we've kind of, again, this is our ugly working version, but you can kind of see, we started going through ones that we thought were very specific to airports, 18B, ones that were more generic, like SU standards and the latest SU requirements, building standards and how we actually display them, ontologies and digital twin languages. So like, how are we going to relate these elements together? Willow has got a GitHub released airports ontology, IFC, and how does that fit in? We started working those standards through, and then we were able to kind of like further update this with like, well, where is 18B going to apply, and how is this going to feed across, and where do we start feeding in the airport ontologies? And the reason for all of this is because we know we're going to start aiming at some of these outcomes, and we need to kind of build a way to easily get to them, so we can say, okay, this is the thing we want. These are the groups that feed into it, the requirements. These are the governing bits of standards. And I think that, Jerry, just to your point from earlier, if I hop back to the hype cycle, and maybe you can make this for me here, but the reason we're approaching it this way is because we know that we're in the trough, and even on this call, there's like, and you can feel it. People are just like, yeah, but what is it? What are you talking about? Kind of thing. So like, how do we get out of that and start moving into something more concrete? So maybe, Jerry, I'll let you talk about it, because this is your.
Yeah, no, you're heading down the path that I would take. The idea with it is the notion that you set up methodologies and standards. It's a requirement to be able to do automation. And effectively, that's what you're doing with the digital twin. You're automating it. And I'll use some examples just because they're helpful. You ever go to a hospital and like every possible alarm is beeping and you're like, what is this? And you see nurses and doctors just ignore it and go just on with their life. Well, that's alarm fatigue. And some of that has to do with not having consistent protocols about what does a yellow light mean? What does a red light mean? What does a blue light mean? And those are all varied, and it's very chaotic, and it's very hard to consume it. You'll see somebody put up a dashboard and you go, oh, cool, a dashboard. And then you look at it and go, well, this little area, red means something else than red over here, etc. And the whole process of doing a digital twin is normalizing that, simplifying it. So that's inherent in building the notion of a smart airport. I mean, if the twin is not a palatable term for you, it's a smart airport is maybe the way to think about it, or smart whatever, where you're adding intelligence to what you're doing. Anyway, so I'll stop there.
Yeah, we're hoping that to climb this slope, by adding these methodologies and best practices, by coming up with some second gen kind of products and examples of those use cases where it's going, that it'll start to drag some of the the haze of unmet expectations into the light, that kind of thing.
Yeah,
I think.
Hey, Chris, can you go to the lower left of that slide?
Sure.
Just talk a little bit about it, because sometimes you have to see things a couple of times and go, well, what does that really mean? And so again, kind of this notion of transforming the way we do things, or the way we think about things. It's very different to operate on exception-based activity versus rule-based. I'm going to look at everything. Well, you look at everything, you're fatigued and tired and you're worn out. But if you look at only what you need to look at, which has been through an escalation process, which has been through a rigor, that's like, by the time that, if it's shining red, you need to do something. It's not like, oh, hey, look at me. It's like, do something. And so it's sort of that notion of filtering out the noise. Another way to think about it is visual flight rules versus instrument flight rules. So for those of you who are a pilot, it's a very different deal. It's a very different airport that you're doing in flight rules. Clear skies, you can see the runway, you can navigate on the roads. That's kind of how you do it. But instrument is like it's raining, there's wind all over, and you can't see anything, and you're going to trust and land with those instruments. So it's cranking up the level of capacity, and that's why you would move to that world. And so there's just we're trying to instill, here's the basic frameworks in which you can build this with some level of confidence that you're doing it right. And part of that is just the hard work of focusing in on standards.
Mm-hmm. Absolutely.
Yeah.
Yeah, we're at less than 15 minutes. I hope that what we were describing kind of has solidified some of this in your minds, and that this concept of mapping an outcome and then understanding what requirements and standards would set, and then who would have to feed in to achieve that, makes sense, because that's ultimately what this kind of working group is doing, is trying to pick a few of these and show how it connects together to achieve that outcome. And we have some examples in here that that Jerry could definitely talk through, places that are doing this now and kind of how they're doing it. And I think what I like about it is that whenever you go through these really good digital twin examples, you can kind of relate it back to that framework. You can say, oh, okay, this is the, what static data did they have to do that? What active information was required? You know, like, then what did they do? How did they manipulate those things to get this output? You know, you can kind of go through each one of these and say, oh, okay, yeah, I can kind of see how this fits a little bit. It gets a little harder when you get to the twins of twins and, you know, this organizational level. It's a lot more complicated, but, you know, in discrete and then, you know, like system sides, I mean, there's some really good examples. Before I do that, I don't know, Jerry, we could do that, or before we do we want to just see if there's more questions that are coming in, or if people have other thoughts that they want us to dive in on?
Let's take a breather and see if there's some questions people really would like to have answered. And because I know we've thrown a lot at people today. We live and breathe it so much, but it might be, you know, like, oh, geez. So let's see, how about we check the chat?
It looks pretty clean to me, unless there's been some private chats going on.
Yeah, it looks like you've answered the questions. The only one that we see is, how are you publishing digital twin data requirements? Do you find these in RFPs, or is there some other document?
You mean, I guess, let me just start and maybe I'll get there. The digital twin data requirements, if we think about how we would do this as a service for someone, it would be to figure out what it is that they want to achieve and then understand the data required. And I think that depending on what it is that's aimed at, that could be right. It could definitely be part of an RFP. It could be that we advise the owner that for every new capital project, there's a certain amount of information that they need to be asking from design and construction. It could also mean that we need to have a set of published requirements that are going to their operations teams, because we need them to collect a different set of information. It could also mean that they need to publish and produce that by having some sort of data stewards, you know, put in place to govern and organize this across. And so I think that it depends a little on where you want to go, but it's usually across multiple facets like that. Because if they have this idea that they need to see this thing, they need to do this thing, and it requires a change to the way that information is flowing to them, and I should probably be talking over the diagram, right? The real-time information, the spatial information, what is required to get to that? There will be data requirements that come through that, and this information is authored from a whole different set of people. Like, you can kind of see the financial side, there's going to be a whole financial side and operations team that may need to adjust the information that they produce and store it slightly different to make it accessible. But that could be just as true for the BIM information being authored in capital and construction. And so those data requirements, and that's why the little data blob was kind of all over the place here, because we're seeing this kind of, yes, the requirement here is going to be a little different. And depending on, for your outcome, how many little data blobs you end up with, that would tell you where and when you need to require it. You want to add anything to that, Jerry?
Sure, yeah. Can you go to where I put my pointer? It's over in the illustrations section, kind of towards the bottom.
Move it around for me again.
Okay.
Yeah, right there, yeah. It's a little grainy, sorry.
Yeah, no, so this is one vendor from Dassault, an example of what they did in terms of kind of like figuring out an illustration of how you would orchestrate everything into a platform.
Did we lose Jerry? Was it just me?
Seems to be frozen.
And machines, capability of machines, all those things, and you should collect those in the beginning. Are you hearing me okay?
We lost you for a minute there. I think you started it, and then we missed the middle. So if you want to take another quick crack at it.
I'll take another. Just a second. So the idea is that you would go find a piece of information that you need to flow through the whole thing. So let's just say it's checkpoints. You need to know the types of machines and their capacities. You need to know layout and configurations. You need to know ultimately people counts and wait times, and you want to know how you're going to communicate that back to people. And so you have all those requirements up front that effectively are all about automating a process. It's about being smart. And you would want to take that and go all the way back to the beginning. Do I have the current machine configuration, the layout? Can I put it in there? Can I create an object against it? Can I match data against it? Oh, guess what? We're missing people counters. Oh, well, let's drop some cameras into our design so that we have them in there. So what you don't want to do is get to the point where you're ready to turn on the checkpoint and you're like, oh, we missed this, we missed that. Oh, it's too late. If you would have told us to cable in some cameras, it would have been a no-brainer earlier. So I think it's really important to actually do it as part of the overall bid and thinking process. And because this is where the tools are going to evolve to doing this. Can you go back into like where that airplane is, and then how they're doing turnaround there? And for instance, it's not only one organization that's going to be doing some of this kind of work, it's others as well, and they're going to expect you to do it. So like if you look at what it takes this is what's involved in, this is a business architecture from an airline being able to do turnaround. It's a ton of things that happen within that environment. So they would have this conceptual diagram. And on the left is a tool that would allow them to achieve data feeds to the diagram on the right. And, airports may offer this as a service because they might not want to set up these things at every airport. So you can find value propositions, you can find revenue opportunities, and turnaround time's massive for an airline. They'll beat you over the head with it and say, it costs us $76 a minute, for delay. And you're like, okay, I can do the math. That's a million. And that sort of thing. Or if you can get one more turn a day at a gate, say, what does that mean? Well, a gate costs you $20 million to build. And you're like, oh, okay, well, that's real money. And so this is how you would think about this. And you would want to say, this is kind of the big picture, the big value, and then kind of look at it. Well, how can we do that exactly? So I'll just throw that out. That's probably a little divergent from the question, but I found it interesting,
Yeah, it sparked a couple of other thoughts, actually. I've got one. I think the digital twin should be something like a COBie standard, but more advanced, or absorb COBie. Question, are data schemas like COBie facilitating implementation of twins? And so I think to that, I'd like to talk about the IFC data standard a little bit. We've talked about, you could kind of see we were thinking about, okay, before we got over here, we were like, where do data sources come from? Information from capital, from EA, from finance and program management, and what schemas. And we also have mapped COBie in particular coming from BIM, right? IFC, COBie, Uniclass, like what classification systems are you going to use? And I think to have a really well-defined, well put together COBie playbook that includes all of the, spots that are ready to be filled out that work for an organization is going to be a massive part of this. So yes, I can definitely see a need for that. I don't think that most owners that don't have that well-developed kind of COBie playbook, I call it a playbook because that's the way that most people that have a good one are kind of rolling it out. If they don't have one, then it's a lot more work than they think it's it's not out of the box. And I know that COBie is being updated or changed, right? I think I saw something about that, but I'm not 100% on that. But I think it plays into more places, because if you think about how financial is tied in, then you start to get to like, well, what is a project and what is a facility, and what hierarchy we're going to use to describe things spatially? how are we gonna tie these things together? You come up with some threads that have to feed their way through to achieve an outcome that almost always are going to pass through COBie, especially if there's, you know, static and if there's a model associated with it, but need to get fed into other systems. And that's where the data ontologies are interesting. So if you haven't read about or looked at digital twin ontologies, data ontologies, these kind of relationships and how they're all fit together, I think that that's going to be another really key point, because in order to achieve a lot of these outcomes, it's not enough to just kind of like follow a linear data stream. People need to approach it from a relational standpoint and understand how things are all connected together and what they feed and what feeds them. And it goes a lot to the way that we use Google search now. You know, it kind of knows what you mean when you ask something, because it knows that there's a lot of other things that are associated with that. We're going to need to start adopting that kind of database or data framework. I'm not a data scientist or data engineer, so I really don't know what I'm talking about. But to say that, I think, is another good way to do it. And just to give you a feel for how we're approaching that with IFC, I mean, IFC has some kind of like very well published hierarchies, you know, they're domain layers, right? On top of their shared systems, there's core layers, and then there's, you know, resource layers. And we are trying to figure out what's missing in IFC in that data framework. What do we have in the current schema? Make a standard for the missing items, move those for approval, and then push them back, right? And so this is the kind of framework we're talking about, and we're starting to look at what does a hierarchy look like for airports? Can we tie that to the hierarchies in 18B and other systems and make sure that it's compliant? And then how does that relate to other classification systems, and how do we put this together? So there's data work being done in these working groups that's about kind of the questions you're asking, and I think a lot of that would feed back in. So that was a long answer. Hopefully that got there, at least in part.
It's a great point, Chris, and that FAA advisory graphic you have there, you know, it's going to be revisiting a lot of that stuff and kind of reformulating it a little bit and moving ahead. It's not going to be all from scratch. You know what I mean? There's a lot of this has already been done. It's just going to be, okay, how do I put that into that graph database technology that you were just mentioning, this relationship-based tool? The fortunate part about it is those are very forgiving tools. So where a SQL is not forgiving, and some of these tools allow you to relate them from all kinds of different directions. That's what makes the search engines so valuable. They find anything, amazing things. So this will be one of those foundation pieces that we build from, is a lot of it. And fortunately, like the FAA is already a bit of a standards body for the industry. Yeah. Well, I think we're at the end of our time here. So we should probably wrap it up. And really appreciate everybody's time and appreciate the opportunity from buildingSMART to give us this chance to present and get this word out here. And we certainly invite you to participate, whatever you can, whatever kind of time you have available. That would be awesome. Chris, do you have any other closing remarks?
No, 100%. Someone did ask if the schematics can be shared, and I would love to send a link out to this working mural board. There's a lot of people that have fed into it, and I don't know what they want shared. So as soon as we can get it cleaned up, absolutely. We want this. I would have loved to have given it to you today. And so I'd love to get this out to everybody, so that not only can you go and use what's in there, but maybe you could add to it, right? So thank you so much.
Yeah. Oh, everyone's welcome. Thank you.
Thank you, Chris. Thank you, Jerry. And thank you, everybody, for tuning in. This session is recorded, and we will be sharing it on the buildingSMART USA website. So stay tuned.
Awesome. Thank you. Have a great day, everyone.
Thanks. And Matt, absolutely not. I love the question. Don't worry. It's like, that's actually where we started with this, which is that we wanted to take a more practical, tactical approach. So it was right in line with where we came from. So I really appreciate your feedback and thoughts, and never change. Never change, Matt.
All right. Thanks, everyone. Bye.